All right, guys. So today we're going to start covering 8.5, and we'll cover 8.5 in two parts. So today's learning target is that I can add and subtract rational expressions with or without common denominators. So think about dealing with fractions in general, just like simple fractions, and multiplying fractions is more. Adding or subtracting fractions is more difficult than multiplying or dividing, because with addition or subtraction, I need a common denominator, right? So that's an extra step that makes addition and subtraction a little bit more difficult. So just to review what that looks like, looking at this example here, adding 1/2 and 1/3. With multiplication, we just multiply straight across. But with this one, we'd need that common denominator, so we would change that to 3/6 plus 2/6, and then we can add numerators, right? So anyways, that's kind of a preview into why this lesson might just be a little bit tougher than our last lesson, which was multiplication. Okay. All right, so on example 1A, this would be an example of one that we might consider a layup, because you already have a common denominator, right? So if we already have a common denominator, all we do is add numerators, right? So it's 2/5x plus 3/5x. So that's just going to be 2 plus 3/5x, so 5/5x. You do want to look to divide at the end if you can, reduce at the end if you can. So 5 and 5 obviously have a common factor of 5. So we would reduce that down to 1/x. We want to state any restrictions, so we know that just x can't be 0. And so that's an example of what an easier one might look like. I'm going to leave B for you guys to do. Let's look at C, and then we'll kind of see if we have any questions, and then let you all try one. All right, so looking at C, if you look at the filled out notes, you'll see that I worked example C and not the most efficient way possible. Like what I did was I got a common denominator, but not the lowest common denominator, which is fine. You can always do that. But we're gonna do it a little more efficiently on our live notes, okay? So before I just I can always, to get a common denominator, I can always multiply the left fraction by the right hand denominator, and vice versa. But I could be a little more efficient, like I was kind of alluding to. So let's think about what our lowest common denominator would be. All right, so I'm looking just at my denominators right now. What's the lowest common factor there, right? So for 2 and 5, the lowest number they both go into is 10. For x squared and x, the lowest factor that they both go into is x squared. And for y and y cubed, they both go into y cubed. So basically, that's the thought process to come up with the lowest common denominator, right? So we're going to change this to something over 10 x squared y cubed minus something over 10 x squared y cubed. That's the idea, right? So then we think about, all right, what do I have to do to 2x squared y to make it our lowest common denominator? And the answer to that is I need to multiply it by 5y, okay? So we're going to multiply this one by 5y over 5y. And on the right side, we need to multiply by 2x. It looks like 2x over 2x. So that should give me my common denominator on the bottom. So you might just double check that. It looks like it will, and it gives me whatever it gives me up top, right? So 5y times 5 is 25y. 2 times 2x is 4x. And a lot of times what you'll have, like with our numerators, are like where you can combine like terms. 25y and negative 4x aren't like terms, so we just have to write that as a binomial. All right, so our final answer then would be 25y minus 4x over 10x squared y cubed. And then any restrictions. So on this one, we have multiple variables, so we'd say x can't be 0 and y can't be 0. Those are the numbers that I could plug in to make my denominator 0. Okay. Anybody have any questions so far? All right. So let's have you guys then just try to do as much as you can on B in the next 2.5 minutes. Feel free to compare with folks around you, and we'll go over it here in just a minute. So you think, what's my GCF? And then multiply by whatever it takes to make your current denominator the GCF. But add or once you have that, add or subtract your numerator. Reduce if you can. All right. Anybody want to try to volunteer just the final answer? Any bold souls out there? Shrieker? 21 plus 30x all over 35xy. Perfect. Yep. So that's it, and I can go over this if you guys would like, but it's 21y over plus 30x over 35xy. And then the only thing I would add to that are the restrictions, which would be x and y can't be 0. All right. Anybody have any questions on that? Yes. Oh, yeah. I did. It did look like an yeah, just a semicolon. Yeah. No, that's okay. That's all right. That's a valid question. Anybody have anything else? All right. So you can see more detail on the notes if you really do have a question and just don't want to ask. So you know, all that would be on the notes anyways. Moving on. Okay, let's go ahead and look at D. So we have to be careful of on these ones where you can factor is, you know, you might just look at it and think, okay, don't write this, but you might just look at it and think I can multiply this one by x squared minus 9 over x squared minus 9. And then this one by x plus 3 over x plus 3. And that will give you a common denominator. That can always give you a common denominator. But it's going to leave you with a kind of a mess, okay? So in order to get the lowest common denominator, which is going to save you a lot of work on the back end, you want to go ahead and factor first, okay? So let's rewrite the left fraction as 8 over, that's a difference of squares. So x plus 3 times x minus 3. And then we can see that we're a little bit closer to a common denominator than we might have recognized without factoring. So I don't need to make any change to the left-hand fraction. It's already got the LCD, right? So I can go ahead and just rewrite it the same way. 8 over x squared minus 9. And then on the other side, I'm not quite there, right? So it's missing the x minus 3 factor. So we're going to multiply by x minus 3 over x minus 3. So it gives me whatever it gives me up top. So that'd be 3x minus 9. And then I have that common denominator of x squared minus 9, or x plus 3 times x minus 3. At this point, when I add my numerators, I do have like terms, so I'll go ahead and combine like terms, and then we should be done at that point once we add. So so overall, I'd have 3x minus 1 over x squared minus 9. And we want to say that x cannot be, think about factored form here, x can't be plus or minus 3. All right, so that is that's what one looks like that would involve some factoring. Example E is one where you can't factor, so you would basically multiply the left fraction, so we can see it on the screen. Multiply the left fraction by x plus 5 over x plus 5. Multiply the right fraction by x minus 3 over x minus 3. But just to save time, we're going to skip that one for now. If we have time at the end, we'll come back to it. These ones on the back might be a little bit tougher, so I want to make sure that we show as many of those as we can. So let's just start with E. Before I do start, does anybody have anything before we keep rolling? All right. So looking at E again, just to make sure we don't end up with like a messier denominator than we need to, let's go ahead and factor over here. So I'm going to actually do that above. So that'd be multiplies to 2, adds to -3. That'd be -2 and -1. So factors to x minus 2 times x minus 1. And then we see the kind of that common factor of x minus 2 in both of them. So So that means my LCD is going to be this, right? This is my LCD, right? So my right fraction's good to go already. And my left fraction is just missing that x minus 1 factor. So multiply by x minus 1 over x minus 1. So up top, that's going to give me 4x minus 4. The other fraction was already good to go. And then it's just a matter of combining like terms. So actually, this one is a lot like the one we just did. So anyways, 4x plus 6x is going to give me 10x. Minus 4 just stays minus 4. So 10x minus 4 over x squared minus 3x plus 2. You do want to think about what 10x minus 4 looks like in factored form just to make sure it doesn't have an x minus 1 or x minus 2, which would tell us we had to reduce. But if I factor out a 2, that's going to give me, 5x, minus 2, so it doesn't. So we can't reduce, so I'll just leave it as is. And then my restrictions are x can't be, thinking about the factored form there, so x can't be 2 or 1. All right, so let's keep going and do h, and then I'm going to have you guys try a couple just to see if you're catching on, okay? So I'm skipping down to h, going diagonal from what we just did. All right, so since we can factor both denominators, I'm going to just rewrite both fractions in factored form. So that would give me y over 4 times y plus 2. And then minus 1 over y times y plus 2. So again, this is not really obvious without factoring, but now we can see those factors are actually pretty close. They contain that common factor of y plus 2. So based on what I've shown, can anybody tell me what my LCD is going to be? You might be able to see it and just not know how to say it. Yeah? Okay, yeah, so 4y squared plus 8y would be it simplified. I'm just going to write it a slightly different way, but that is correct. And if you can see it, I would just write it that way. So yeah, it's just going to be 4 times y plus 2. Okay? Or like Caitlin said, 4y squared plus 8y. Okay? So that tells me then that I'm pretty close, I'm pretty close to having a common denominator. All I need to multiply by on the left one is y over y. And on the right one, 4 over 4. All right, so what that's going to give me on the left one is y squared over our common denominator. Let's leave it. Yeah, I'm just going to write that in factored form for now, just because I know at the end we're going to have a common factor. Not that you should be able to see that at this point, but that's why I'm writing it in factored form. All right, so y squared and minus 4 aren't like terms, so we just write that as a binomial, y squared minus 4. So at this point so far, we've been pretty much done at this point, but you always got to be careful, you know, to try to reduce at the end. Like, so if you entered this answer, MathXL might say, or if you entered y squared minus 4 over 8y squared, or sorry, 4y squared plus 8y, MathXL might say, okay, this is correct, but it's not simplified. So you got to be careful here and look to reduce if you can. So you know, what do we have? What do we have up top? What do we call that type of binomial? Difference of squares, right? So when we factor it, we see that we are not reduced. So it's going to be y plus 2 times y minus 2, right? And we have that common factor of y plus 2. So we can reduce there. So my best answer, my most reduced answer is just going to be y minus 2 over 4y. And then we have to include all restrictions. So we kind of think back to how it was right there, or anywhere really. So we see that we have zeros at 0 and negative 2. So those would be my restrictions. Y can't be 0 or negative 2. All right, it's kind of off the screen. If you can't see that, that says y can't be 0 or negative 2. All right, so I know I've been talking a lot, and so at this point, I am going to let you guys try to get as far as you can on F and G. Some people may get all the way through them. Some people may still be working on one of them after 5 minutes, but just get as far as you can. Feel free to work with somebody around you, and we will talk about those here in about 5 minutes. And if you're really working fast and you get both of those done, you can feel free to look at E as well. But I would say you'd be doing good, you know, to get most of the way through both of those. What's that? Yeah, just sign out. Oh, and Roxy, I should have said congrats on your all's big win. I heard it was a dazzling performance. Come on, I could be writing headlines or something over here. Well, good. I'm glad y'all did good. Hopefully you had a chance to have a little fun down in Florida too. I'm sure you were pretty busy, but hopefully you at least got to eat a good meal or something. All right. So what I will do here is I'm going to kind of just write up the answers, and then you know, if at that point you feel pretty comfortable and confident, I'm gonna just say you can go ahead and you know, get started on the MathXL if you want. Obviously, feel free to take a little break before you do. But I'll do answers for both, and then I'll kind of work through them and give more details for those of you who either A, didn't get finished, or B, our answers don't agree, right? So so then we can get into more specific questions, all right? But obviously, if you got the answer right, then you're not going to probably have any questions. So that's why I'm going to start there. All right, so final answer on F is going to be well, if I can find it. So that's going to be negative x plus 23 over x squared plus, sorry, minus 25 or x plus 5 times x minus 5 times x plus 1. Or if you simplified that out further, you may have to on MathXL. I'm not sure if they would accept that or not. But if they didn't, the more simplified denominator would be x cubed plus x squared minus 25x minus 25. Okay. So so anyways, that's it. And then your restrictions are that x can't be plus or minus 5 or negative 1. So that's just the answer. That doesn't give you a whole lot of information, but I will come back and give you more on that. And then your answer for the next one, if you even got that far, was, let's see, 5x squared plus 14x plus 21 over 3x squared minus 12x, or 3x times x minus 4. And then your restrictions would be 0 and 4. X can't be 0, x can't be 4. So like I say, if you feel pretty good about those, you know, feel free to get a head start on your homework. We're going to be talking more about this lesson tomorrow. That said, I am going to show these. So did you have a specific question before I kind of show them? So it's what makes your denominator equal to 0. Does that make sense? Yeah. All right. So basically, you're using like, you know, when we're solving quadratics, we call it the zero product property. But it's like you just set your denominator equal to 0, basically. All right, so I'm going to show, like I said, more details on these. So if you are working ahead of me, working on something else, just do so relatively quietly so people can pay attention and get what they need, okay? So stay with me if you had questions. Feel free to go on to MathXL, though. You won't offend me. All right, so you would want to kind of factor out both of these so we're not just blindly multiplying. So on this one, it'd be 3 over x plus 5 times x minus 5. And on the other one, we'd have, it'd be x plus 5 times x plus 1. So without doing that, we don't see that they already have that common factor of x plus 5. So then my LCD is going to be x plus 5 times x minus 5 times x plus 1. All right, so that tells me then that I'm going to multiply this side by x plus 1 over x plus 1. The other side by x minus 5 over x minus 5. Okay, so what that gives me on the top of the left side is, 3x plus 3. And then minus 4x minus 20. All of that is just over x plus 1 times x plus 5 times x minus 5. To save a little bit of writing, I'll write x plus 1 times x squared minus 25. Now, what a lot of people do, if you have a binomial, like after a minus sign, is they'll, so obviously, you know, the parentheses weren't there, I wrote them, but if you don't write the parentheses, what a lot of people do is they'll do 3x minus 4x is negative 1x, and then they'll do 3 minus 20 is negative 17. But remember, you need to distribute that negative through, okay? The parentheses that I wrote up there make that more obvious. So anyways, yeah, 3x minus 4x gives me negative 1x. And then 3 minus negative 20 is 3 plus 20. So that's where I get the plus 23. And then, like I say, I'm not really sure. I know I should be sure by the time I give you guys this. I'm not sure if MathXL would take the denominator like that. If not, you would want to just multiply it out. So I'll give you that version too. So you might try this, but if not, they're one x cubed. Sorry, x cubed minus 25x plus x squared minus 25. And then, you know, Madison, to go back to your question, for the restrictions, you know, I always think about the factored form of my LCD, right? So think about what makes those 0, right? So x plus 1 equals 0 gives me negative 1. X plus 5 equals 0 gives me negative 5. X minus 5 equals 0 gives me positive 5. So that's how we got our restrictions. X can't be positive or negative 5 or negative 1. So now that I've shown that, any questions on any of those steps? Yes. So again, just kind of you gotta look at whatever your denominator is, right? So where I'm circling, right, I have basically 3 factors: that, and that. Okay. So if I plug in a -5, that makes that a 0. If I plug in a +5, that makes that a 0. Okay, so that's how I know that I need to use both positive and -5. Does that make sense? In other words, I don't use plus or minus 1 because there's no x minus 1 factor. There's only an x plus 1 factor. Does that make sense or not really?
Yeah.
Okay. So basically, those are the three numbers that if I plug them in, that would make my denominator equal to 0. Okay. All right. So let's go ahead and look at this last one. And like I said, if you already feel comfortable about what I told you, feel free to go on and do your own thing. All right. But anyways, so factoring out my denominators first. Let me just erase this so I have more room. If I factor out my denominators first, I'm going to have 5x minus 4 over 3 times the quantity x minus 4 plus 6x plus 7 over x times the quantity x minus 4. So then my common factor is going to be 3x times x minus 4. So that tells me multiply this one by x over x, this one by 3 over 3. So I would have after that 5x squared minus 4x plus 18x plus 21 all over, let's see, 3x times the quantity x minus 4. So at that point, I have like terms up top. So I need to combine any of those, which is going to leave me with 5x squared plus 14x plus 21. And all that's over 3x squared minus 12x. And then for my restrictions, I'm not really thinking about my unfactored version. I'm thinking about my factored version, right? So basically then I set 3x equal to 0 to get x equals 0. So x can't be 0. I set that equal to 0 to get x can't be 4. Okay, so 0 and 4. So hopefully that helps. If you guys have any other questions, let me know. Let me go ahead and stop this recording, though, so I'm not just talking and taking questions. And that'll be posted at the end of the day.